Hello, my name is Aaron Meurer. I work for Continuum. There's been a lot of buzz about Conda. We heard about Conda this morning at Nick's keynote. The PyPA is going to start endorsing Conda as the solution for sort of going beyond what pip is capable of. So this is the title that's kind of like the very toned down. The title I wanted to use is Conda Solving the Packaging Problem. And so today I'm going to go over basically what the packaging problem is and how Conda solves it better than the existing tools. So what is the packaging problem? Well, here's a brief history of packaging in Python. It's very bleak. We have distutils and then setup tools, and then setup tools got forked into distribute, and we've got easy install being replaced by pip. But ultimately, the packaging problem, if you talk to people, you might get a lot of different answers because there's really two sides to packaging. There's installing packages and building packages. And if you're a user, you probably only know about the installing side. If you're a developer of a library, you really know more about the building side and also the installing side because developers are also users. So some of the ways that we install packages, setup.py, easy install is kind of deprecated, but pip. There's all kinds of system level package managers. So the very basic way to install a Python package, you download it, you run setup.py install. This is great. It works well if it's pure Python. If it's not pure Python, it doesn't work very well, usually. If you have compilers installed and you're lucky and you cross your fingers, it works. Otherwise, you get these very cryptic GCC failed with exit status 1, and then you're banging your head against the wall. But the key thing here is if you're doing setup.py install, you basically are your own package manager. So it's much better to use a package manager, so how about pip? Well, pip also works great, but it's very limited to the scope of Python. And the problem, especially in this community, is that Python is not itself limited to Python. Python likes to link against C libraries and Fortran libraries. So, for example, if you try pip installing H5Py and you don't have HDF5 installed, it's going to run through, and basically at the end it's going to say, I don't know what this define HDF5 or this include HDF5 is in your code. It doesn't know how to recursively go through and install HDF5 because HDF5 is not a Python package, it's a C package. So I think the term that Nick Coughlin likes to use with pip is if you use pip, you're sort of a self-integrator. So on the other side of the packaging problem, we have building. We've got this very complicated history of Python build tools. Some issues. No talk with about the packaging problem would be complete without a little rant about setup tools and distutils. So distutils, very limited, especially when it comes to code that needs to be compiled. We can see that this NumPy distutils, the necessity for NumPy distutils kind of shows this. Setup tools itself is kind of evil. For example, when you import setup tools, that monkey patches distutils, which is why you don't actually import anything from setup tools. You just import setup tools, and everything uses setup tools. It does all this crazy stuff with the entry points and with your imports. The key thing I want to get across, though, is package maintainers really hate having packages that users cannot install. So as a user being frustrated by packages that are very difficult to install, we sometimes we like to have this frustration against the package maintainers, but the package maintainers really hate this. They're not the ones who should be blamed here. So what's the packaging problem? Well, I just mentioned, we've got these issues with distutils. You've got to become your self-integrator or your own package manager, but really these things kind of get dwarfed. The real packaging problem is this. So Anaconda downloads, I'd say about 70% are on Windows. We can't ignore Windows as a platform, even if we ourselves don't use it. But the problem is that many library authors don't use Windows, and supporting it is very difficult, especially from a packaging point of view. And so, well, what about wheels? Well, wheels kind of have the same problem as pip. They're very Python specific. So you can't really build a wheel for HDF5. And also you can't build a wheel for Python itself. And you're still kind of a self-integrator if you're using wheels. And so finally we get to these system-level package managers. We have apt-get. Apt-get works pretty well if you're on Linux. If it doesn't work very well if you're not on Linux. On OS X we've got some, and there's even a few on Windows, believe it or not. But there's really only one system-level package manager that's cross-platform, and that's Conda. So Conda kind of, the way it solves this problem is by elevating itself above Python. And because it's basically Python agnostic. So the only things in Conda that are really, that mention Python are specific to the fact that Conda itself is written in Python. The package format is completely Python agnostic. And so Python, H5Py, HDF5, all three of these are equal level as packages in Conda. It's cross-platform. It works on all three operating systems. It doesn't require administrator privileges, which is something that was mentioned at the HashDisk talk. It's a very important thing. Conda also focuses on relocatability, which allows this non-administrator privileged installations, which is also important for Windows because most people who are on corporate environments don't have administrative privileges to install things on Windows. The way it gets around all these crazy issues that you see with setup.py install is it just installs binaries. So any compiler woes that you would have are gone because it doesn't do any compilation when it installs things. And finally, the metadata is kind of fixed. It's stored statically and separate from the package so that this lets us do some smart things with the way we solve dependency resolution. And so now I just want to give you a very brief demo of Conda. So if I do Conda list, I can see I've already got the wrong thing on the projector. So let me see if I can mirror somehow.
Does Conda have a solution for this?
Okay. So Conda list, this font is too big to have this show up well. Conda list, I've already got Python and its dependencies installed. I want to install something that's typically difficult to install, say SciPy. And so it's downloading the metadata from the repositories, and instantly we have SciPy installed. This is also the world premiere of a new format for showing what's going to be installed here. So now if I want to say Conda install a different version of SciPy, because we have compatibility issues, so Conda install SciPy 0.13. And hopefully this won't have to download anything. And so instantly now I've got a different version of SciPy. I'll get back to the environments in a second. Here's some advanced usage. Just put those on there if you look at the slides later. So digging down, what exactly is a Conda package? A Conda package, all we do is take everything that's installed and tar it up. So everything in the lib directory, everything in your bin directory, and then in addition to that, we have some metadata. So in particular, there's nothing in here that's Python specific. We just Python packages happen to be installed somewhere, and the Conda package packages up that location where they're installed. And the metadata is completely static. It's stored as a JSON file here. So you can have, Conda is, of course, very popular in the Python community, but you can have Conda packages for C libraries, for R libraries. We've got a guy who's added full support for Perl to our build system. And of course, Python itself is a Conda package. As far as installation, all we do is untar the package and then hard link those files into the installation directory. And then we do some tricks to make sure things are relocatable correctly. There's really not a whole lot of things that happen here. It's very simple. So as far as hard linking goes, a very interesting thing you can do there is because we're not actually moving the files, we're just putting them somewhere and then hard linking them. We can hard link into different locations. So here I've got two packages, Python and SciPy. I install Python into the test directory and also into the SciPy-env directory, and I install SciPy into the SciPy-env directory. And because Python is hard linked into both places, there's basically zero cost of having it installed in two different places. And the environments sit on top of Python, so they're completely independent. So there's no need to fiddle with Python path or LD library path or any of that. Each Conda environment is like a completely independent installation of everything that's in that environment. And activating the environment, all that means is putting it on the front of your path. And in fact, you don't really even need to activate if you just want to use absolute paths to everything. So let's the command to create a new environment, conda create-n, and let's create an environment with, say, SciPy in it. And because I'm at the head of my game, I use Python 3, so this is installing Python 3 version of SciPy. And now if I do source, so right now if I type Python, I don't have SciPy. I'm activating this, and as it says, all it's doing is changing my path here. And so now if I type Python, I have SciPy. I'm not going to do anything there. And so I can now create environments, say, with, so something you may not have noticed here. The environment I was in before had Python 2.7. This environment has Python 3.4. So one advantage of having Conda live above Python is that the environments themselves can contain different versions of Python. So one of the great uses of environments is actually switching to Python 3 or from Python 3, depending on how you want to work. It's really, I think, a game changer in Python 3 adoption. It's great for development. It's great if you want to do something and you're afraid you're going to break it. Just create a new Conda environment and you don't have to worry about breaking your installation. Different dependency versions is a very common problem. And basically, reproducibility is key here because everything that you do is basically dictated by the list of Conda packages that you have installed in your environment. And all you need to do is this conda list -- export will create a very special format that you can pipe into a file and then conda install -- file from this file, and that will recreate the environment exactly the way that it was when you did whatever you did. Okay, so the next point is Conda is very extensible. You can build your own Conda packages. To build a Conda package, you create a recipe which contains the metadata for the package and the script to build it. And so an example metadata here. By the way, is my green terminal good? Okay. I get a lot of crap for that.
I'd like to see this on Windows.
If I have time, I can show you on Windows. But so here's the metadata for a Conda recipe, we have the package name and version. We tell it where to get the source from and the requirements. SciPy doesn't have a whole lot of requirements, but you can imagine here we might have some C libraries. In fact, here's the H5Py metadata. Oh, apparently that doesn't have the requirements. Oh, this is HDF5. Okay. So let's see if I can HDF5, H5Py metadata. So for example, H5Py depends on Python, NumPy, HDF5, and when you build it, you need to have Python installed, but not when you run it. And so, and then there's some extra metadata. And then the build, as far as building, all you do is put in the build script what you would do to build and install the package. So here for SciPy, I'm just setup.py installing. For HDF5, I do a configure, and the important thing here is this prefix equals prefix. This will make sure that you install into the special build environment that Conda creates. And so Conda just creates a special environment, installs everything in there, and then whatever was installed, it wraps up into a Conda package. And then the important thing here is that Conda build is just a very, very convenient wrapper. If you want, you can make a Conda package manually just by following this spec document, which basically, so for example, you just need to, here's the info. So for example, for SciPy, you just, here's the metadata directory. You need to make sure that you have this index.json is the most important thing that has the metadata that is required. And then this, there's this list of files that are installed. But it's all laid out in this spec document. Later this week, hopefully, I'll be helping the HashDisk guys so that they can make their HashDisk packages installable with Conda. And then a very important thing is sharing. So we have a nice tool, or a nice website, Binstar. So once you build a package, you upload it to Binstar, and it becomes sort of like a GitHub for Conda packages. And all you have to do is tell people to use this -c and your Binstar username when they Conda install, and they will get your package. So, and I don't know if you noticed the subtlety, the package that I've built for myself here, which is not a Python package at all. And then, or you can run this command down here, and from then on, Conda will always search that person's channel. So I don't know if you noticed when I did a Conda install way up here. Here, all of these dots represents channels that I've got people's Binstar channels in my Conda. So here in my Conda configuration, I'm looking at various people that have packages that I want to download. And so this really expands the set of packages I get from just the ones that Continuum builds, which are the default ones. And Binstar itself is just a really convenient wrapper around the Conda index mechanism. So if you want to self-host your packages, there's basically just one command you need to run, which is conda index. That will take all the packages and extract the metadata into the repo data.json so that the metadata can be fetched statically from Conda without downloading the entire package. And for example, you can put one of these on your own computer and then use a file URL and have your own poor man's channel on your own computer, or you can serve it up with a simple web server. Finally, Conda is completely open source. BSD, we really want it to be a community project. Continuum, obviously builds a lot of packages for Conda, but we would love for the community to also build packages, and we really want this to be the packaging solution that fixes the Python packaging problem. There is a mailing list. I'd love to have more community interaction on the mailing list. And finally, I'd just like to thank Continuum for paying me to work on open source. And also thanks to these people who, especially Elon Schnell, who is sitting over here, wrote most of the code for Conda and is also the reason that when SciPy is released, that within 24 hours, Continuum has a new version of SciPy that you can install with Conda or whatever package. He's very on top of things. Okay, so now I guess we have questions.